All right, hi guys. So today we are going to do a lesson on three-dimensional shapes for math. So we're going to kind of go through some notes with you guys and looking at different shapes and talk about their different attributes. Remember, we've been talking about attributes or characteristics of shapes. So all the shapes we're going to talk about today are going to be three-dimensional. And remember, they're three-dimensional because they have length, width, and height. All right, so let me share this with you guys.
So you guys remember our last lesson was on polygons, which have to be a polygon, you have to have straight lines. So if you have a solid figure and all of the faces are polygons, like there's no circles at all, then it's called a polyhedron. So like Miss Simon just said, we know a solid is three-dimensional figure with length, width, and height, which I'm sure you guys already knew that, but this polyhedron, this is probably a new term for you. That just means that all of the faces are polygons. Just a different way to name a solid.
Remember yesterday we talked about how polygons just have to be a closed shape with no line segments that cross and no curves, okay? So a lot of these shapes that we're gonna give names, we can also call them and classify them as polyhedrons, okay? So just like two-dimensional shapes have different attributes and characteristics, three-dimensional shapes have different attributes and characteristics. So we're gonna go through what those attributes will look like and what we call them, okay? So we're gonna use this three-dimensional shape here to help us, okay? Many of you might look at this and know that this is already a cube, but these characteristics that we go through are gonna kind of tell us why it is a cube. So the first one we're going to talk about is a face, okay? So a face is the flat surface of a polyhedron, okay? So we can see here that the face of this cube is that flat surface. And a three-dimensional shape has many faces, okay? This particular cube, we can count up and see that it has 1, 2, 3, 4, 5, and 6, okay? So it's that flat part. Then we have a vertex. Okay, a vertex is a point where three or more edges intersect, okay? So it's kind of that point on different shapes, all right? So if we look at this cube, again, we see that there's multiple vertices here, okay? We can see that there's kind of 4 on the top, and then there's also 4 on the bottom. So we're gonna have a total of 8 different vertices here. So we can see that those are those kind of pointed parts there, okay? And then finally we have an edge. So an edge is a line segment where 2 faces intersect, okay? So if we look at these edges here, okay, it kind of looks like a line segment bringing those vertices together. Okay, again, we can count up the edges of different shapes as well. Okay, we can see that squares make up this cube. So it has 1, 2, 3, 4 edges on top, 1, 2, 3, 4 edges on the bottom, and then it even has edges that connect those different faces together for a total of 12 edges.
It might be easier to see that on my drawing over here because the example on the notes doesn't show what we can't see, what's at the back of this three-dimensional shape. So usually when we draw 3D shapes, we'll do dotted lines, okay? And then that can help you see all of the parts of the three-dimensional figure. So you can see here that there are 3 edges that we can't see in the on the computer screen, but that you can when you do the dotted.
Okay. So the biggest thing with three-dimensional shape, guys, is looking like Miss Smith said, looking at those ones that we can't really see, okay? They still exist, we just sometimes it's hard to visualize them when they're not in front of us, okay? All right, so our 3 main things.
So polyhedrons. Polyhedrons are all going to have faces, vertex, and edges if it's a polyhedron. There are some solids that we're going to introduce to you guys today or talk about that aren't polyhedrons because they have circles as a part of them. So they're not technically polyhedrons, but they're still solids.
Okay. All right, so the first type of shape that we're going to talk about are prisms, okay? We've learned about prisms before, okay? We talked about prisms when we were talking about volume, okay? We looked at rectangular prisms, and we're gonna learn why different prisms have different names. So a prism is a polyhedron that has two parallel identical bases, and the lateral faces are parallelograms, okay? So we can look at these shapes here and see that these are a type of a prism, okay? These these three faces here are parallelograms, okay? We see how it makes those up. And then we see that those lines, because they're parallelograms, they are parallel, okay? And what we're gonna see with prisms is that the shape of the base tells the name of that prism, okay? So we notice here that these are going to be called triangular prisms, because if we look at that base, the base is the polyhedron, the polygon, a triangle, okay? So we would call that a triangular prism because of that triangle base, okay? And a base is just that bottom face, that face that it kind of sits on, that shape.
Well, that's what I kind of wanted to bring up. The base, if you're talking about a prism, it's the one that has they're the two identical. So this is the same, this is a triangular prism, but if you'll notice over here, I'm going to try and highlight, that's your base. Oh, that triangle is your base. Hold on, let me undo that. Actually draw a triangle for you guys. This is your base in front, and then that's your base in back. And then over here, now, as Miss Simon was saying, on this one, the base is what's sitting on the ground, on the bottom, and then the identical base is on top. Okay, so over on this one, where the bases, none of those bases are sitting like down on the ground, but they're still the bases because they're the two identical that are exactly across from each other, where the other ones are called the lateral faces. And those lateral faces are rectangles, not triangles.
And we can see too, like just like this cube that we did here, our triangular prism has vertices, has bases, faces, and edges, okay? And we can kind of look at those and kind of count those up as we go with the different shapes. So our next shape that we're going to talk about is a cube, okay? A cube is a prism with 6 congruent faces, okay? So a cube we've dealt with, again, when we were talking about volume, okay? Many things like different boxes might be cubes and things like that, okay? But again, it has all of those different characteristics, and that shape that makes up our cube is our square. All of those faces are identical, okay? And I'm sure you guys can think of many different examples of things that you've seen cubes. We have ice cubes, okay, and a lot of different things. You've been dealing with cubes for a while.
So this next shape isn't a polyhedron, okay, but it is a solid figure. It's called a cylinder. And I put it with the prisms, we're talking about it with the prisms because like a rectangular prism or a triangular prism or a cube, the cylinder has 2 identical bases. They're just, both of the bases are circles. And then that's really kind of a rectangular face that's been like curved around the bases. If you were to cut it and unfold it, it would be a rectangle.
Right. Okay, and like you guys have many real life examples that you've seen of cylinders. A can of pop would be an example of a cylinder, okay? A can of soup. And like Miss Smith said, remember, this is not going to be a polyhedron because it has a circle as a base. And we learned yesterday that circles cannot be polygons because they're curved, okay?
And it also, it doesn't have the attributes of the polyhedron. There are no vertex. no edges, because there's no straight lines, there's no intersections.
Right.
So you can't really use vertices or edges when describing a cylinder. It just has, it has faces, but not the other attributes.
All right, our next shape is what we call a pyramid, okay? So a pyramid is a polyhedron that has one base, okay? So it's different because we can see that in this picture, it only has one base, okay? We don't have two bases here. The lateral faces are triangles, okay? So we can see here that these faces are made up to a triangle, and we notice that it comes to a point, it comes to a vertex at the top there. Again, remember our base tells us the name of the shape. So the shape of this base is a rectangle. So we would call this a rectangular pyramid, okay? And it is different, again, because it only has one base, whereas our other polyhedrons we were talking about with our prisms had two.
And if you stop and think about when you think of a pyramid, this is what you envision when you think of a pyramid, like the pyramids of ancient Egypt, or, you know, something like that, is coming to a singular point at the top. Okay, so all of the lateral faces are triangles that are coming up to that singular point. So it only has one base.
Okay. And again, this one we notice, these have the other features though. They do have edges, okay? You can kind of count those up and see there's 4 edges on the bottom, and then 9, 10, 11, and 12, because we have 4 edges on the bottom, 5, 6, 7, and 8, okay? Because we see that our edges come up from each of those points, okay? And also here, we also see vertices because each point on this rectangle has a vertice, and then there's one more on top for a total of 5, okay? All right. Our next shape is going to be a cone, okay? And a cone, again, is not going to be a polyhedron because it has a circle as a base, right? And remember, our circles are not polygons, okay? So this is not going to be a polyhedron, and we call this a cone, okay? But we do notice about a cone, though, that a cylinder does not have, okay? It has one circular base, and it has one vertex, okay? But we see it does not have any edges because, like the cylinder, it's kind of a curved around shape, okay? We can think of cones really when we have like birthday cones for ice cream, or we have like party hats that we put on. We have a lot of things that could be in the shape of cones, okay? All right, and our last shape that we're gonna kind of talk about is a sphere. So it's a round solid figure, okay? It's kind of different than all of our other shapes because it does not have any faces or bases or edges or vertices at all, okay? It looks like it's made up of our two-dimensional shape, a circle, okay, but it's round, all right? And we see as many spheres in our lives, okay? Basketball, any type of ball that you guys are playing with, okay? Like a tennis ball, for example, that would be in the shape of a sphere, okay? We talk about Earth as Earth being in the shape of a sphere, okay? So there's lots of different things that we could do and show that make up spheres.
And to be a true sphere, you're going to have, like, every circle has a center of the circle. Right? To be a true sphere, when you go from the center of the sphere to any point outside, to any of its edge, it would all be the same distance. So from the center of the circle to the outside is all the same distance, which is the same. That's, you know, that's what makes it a true circle too, is that from the center to the edges is all the same. So it's just doing that in a 3-dimensional way. All right. Ms. Simon, you want to practice? Should we do some practice with edges and vertices? Finding how many?
A few practice ones.
All right. So this first shape I'm going to draw for you guys. Marker out for a second. Sorry. Okay, and then I'm gonna, with the dotted, I'm gonna show you what you would not be able to see. Okay, so this is a three-dimensional figure. If I wanted to name it, I see that it has two identical bases. So this is going to be a prism. And then I'm gonna look at those bases and what are those bases? The base has 1, 2, 3, 4 sides, okay? So it has 4 sides. It's not a rectangle. It's not a rectangle. It's a trapezoid. Okay. So this would be a trapezoidal prism. You just look at what the base shape is and then give it its last name of prism or pyramid because it doesn't have any circles. It's not one of those special ones. So let's start with our faces. How many faces does it have? Well, anytime I have a prism, I know I have 2 bases. So that's 2 faces, 1 and 2. And a trapezoid is a kind of quadrilateral. So because it's a quadrilateral, I know that it's got 4 other sides. So I have my 2 bases plus my 4 lateral faces. So I could look at the 3 I can see, 3, 4, and 5. And then there's also that rear face that we would, that would be in the back for 6. So this has a total of 6 faces.
All right, and
Now the next thing
helps us too, guys, because once we recognize those bases, then since we know our base is a quadrilateral, we know it's going to be 4 more for a total of 6.
Yeah, so prism tells me it's 2, trapezoid tells me I have 4 more.
Okay.
Then I'm going to go ahead and count up my edges, okay? So I know that each of my bases has 4 edges because the bases are quadrilaterals, they're trapezoids. But sometimes as you're getting used to it, it doesn't even hurt to just go in and trace it. 1, 2, 3, 4. So I've got 4 there. And then another 4 for this base. And then I need to connect. I need to connect those bases, right? At each of the vertices. So that's going to be another 1, 2, 3, 4 edges.
Okay.
For a total of 12.
All right, so we know that trapezoid each has 4, and then we have to connect them. So we know we're going to be adding those 4 3 different times to get 12. Okay.
And then the last thing that we want to count up is our vertices. So these are each of our points. Okay, there aren't any vertices on the lateral faces because that's where they connect to the base. So all we need is to know, we just know that there are 8 because there are 4 on each of the 2 bases.
Okay, we have 4 on the bottom and 4 on the top for a total of 8. Okay.
Okay, give me just a second. I'll draw another one.
Remember, guys, when we're naming our shapes, make sure you guys are looking at those bases, okay? And then we'll see whether it's a prism or what that shape is. That base, okay, tells us what the name of that shape is going to be.
All right, so I'm going to draw another one for you guys. I'm going to start with a triangle. Okay, and then I'm going to go back here. Okay, so before we get started counting everything up, let's take a second and see what we notice about this 3D shape. Okay, so what I'm looking for is, what is its base? Does it have two identical bases, or does it just have one base and then all the lateral sides are triangles? Okay, so while I do look at this initially and think, oh, it's coming to a point at the top, so I kind of want to say it's a pyramid, but it doesn't really have one vertex up here at the top, right? It's extending back there. So I actually have a prism here, because this triangle is my base, and then I have the identical triangle that's behind it. Okay, so even though it's not on the bottom, it's not what's on the bottom of the figure, this would be a triangular prism with two bases. So now we can start thinking about how many, counting up faces, edges, and vertices. Well, what do we know? We know it's a triangle. So I know that the base has three sides. Okay, I know that I have two bases. So anytime I want to do a prism, if I'm counting the faces of a prism, I know I have two, because those are the two bases. And then because it's a triangle, I have three lateral sides. So the 2 comes from it being a prism, and the 3 is the 3 lateral sides that make it into a triangle. Now I can go in and count up my edges. So I know that both of my bases have 3 edges, 1, 2, 3, 1, 2, 3. So it's 3 plus 3. And then I also need to connect them. And to connect those bases, I'll be connecting them at 3 different points as well for 3 more edges. So hopefully you guys are seeing this pattern here, because with the quadrilateral, it was 4 plus 4 plus 4. And then we do the vertices. Those are just the points, 1, 2, 3, and 1, 2, 3.
Okay, so we have to have a total of 6 vertices there. All right, guys, let's do a couple more. Okay, but I want us, just because we are looking at these prisms, don't forget those ones who are not polyhedrons. Okay, so don't forget about those cylinders and those spheres. Okay, and those cones and stuff like that, because those are important as well.
Sorry. Okay. Markers are not cooperating. All right. So this one is going to be pretty obvious as I started out here. All right. So if we take a look at this solid, what do we notice about it? Well, it's coming to one point at the top, and I only have one base. So this is going to be a pyramid. Now I look at, what is the shape of my base? My base is a triangle. So this would be a triangular pyramid. Now I want to show you guys something. If we were to, which we will be later in your math project, you guys are going to be creating these out of what's called nets. So what would this look like as a net? Well, my base would be a triangle. Okay, so there would be like a triangle, and then there would be 3 other triangles. This is what this would look like if I were cutting it out and folding it into that 3-dimensional. This would be my base, B for base, and then I would have 3 lateral sides. This can be helpful for counting your edges and just for different things. If you kind of visualize it like that. So when we look here, we know I have 4 faces because I only have one base. So because I'm a pyramid, I only have one base, and then I'm a triangular pyramid. So I have my 3 lateral faces.
Okay. And the nets do a good job in helping you guys figure out those faces because you can clearly see that there is 4 there.
Mm-hmm. And then the edges are pretty straightforward. Just you've got 3, 4, 5, and 6.
Okay. So you have 3 that come from that bottom base, and then you have 3 that connect it all. And then that final one is going to be your vertices, guys. Where you have 3 at that bottom base, and then 1 at the very top for a total of 4 vertices. Okay. All right, so the last one that we're gonna do, guys, is the one that you guys see a lot, okay? We know and we use a lot, a cube, okay? Our last one's gonna kind of be a cube just so we make sure we can get, because our cube has lots of different edges, lots of different faces, lots of things that are kind of going on with it. So we wanna make sure we include all of them, okay? So yeah, we're gonna look at Miss because that's way easier to see than mine. Okay. All right. So we're first gonna let's look at those faces. Remember, a face or a cube is made up of all faces that are squares. So all of those faces are congruent. Okay.
And because a cube is a kind of prism, we can say, okay, well, we know we're going to start with those 2 initial faces because every prism has 2 bases. So those count as 2 of the faces. And then a cube is made of, a cube is when all of the faces are squares, and a square is a quadrilateral with 4 sides. So we have 2 plus 4 for a total of 6. So we still fall in that pattern for prisms. You take 2 and then add the number of sides that the bases have.
Okay. And then we can kind of follow that same pattern when we're talking about edges. Since both of our bases are quadrilaterals, each of our bases is going to have 4. So we have 4 plus 4 is going to give us 8 on our 2 bases. And then each one is going to need to be connected. So we're going to add 4 more for a total of 12 edges. Okay.
And then the vertices are where those edges intersect. So there will be 4 and 4.
Okay. All right, guys, so hopefully this video was helpful. Okay, for your Google form, we're gonna kind of have you guys classify a couple 3D shapes based on their bases, and then you'll have a few, well, you'll have to count the faces, edges, and vertices. And like we said, this is gonna come in handy when you guys are working on your geometric city project, and Mr. Skiak will get more into this next year in 6th grade, right? All right, so hopefully you guys have a good day. And if you guys have questions, we'll be available at 12:30 for the Zoom if you guys have questions after this video. So have a good day. See ya.
Bye, guys. See you later.